That's,
Shit's getting short.
you hear me okay?
Yeah.
Yep.
Right. So homework was using kind of combinations of the chain product quotient rule. Any particular questions you want to go over?
18, 19, and 20.
18, 19, 20. Any other ones? No. The rest of them are okay, good. Sorry, my book isn't opening up. I can find it here. Okay. 18 x minus 1 to the power 3. Okay. Right, sorry, I think they've changed the app for the book, so it's not opening up. So question 18 was this function here, x minus 1 to the 3 over 2. And, oh, sorry, thank you. Sure. Thanks. Okay, we good now?
Yeah.
All right, so this is question 18, wasn't it? X minus 1 to the 3 over 2 minus 3 times x minus 1 to the half. So basically, remember what we said with the chain rule, we want to differentiate what's in the brackets, which is just 1, okay? And then you apply the rule as normal, as if this was just a plain x. So we bring down the 3 over 2, and then we take away 1 to get our new power. So you have 3 over 2, x minus 1 to the half, and we only have to multiply it by 1 because when you differentiate this, you just get 1. Is that okay? Is that all right, guys?
Yeah.
Yeah.
And in this one, we've got, now a constant in front doesn't matter. It's just going to stay in front, all right? So it's 3 times. Now, when we differentiate the x minus 1 here, we still just get 1. And then we kind of pretend that's just an x, bring down the half, keep what's in the brackets, and take away 1 to get your new power. All right? And then we rewrite that as roots. So you've got 3 over 2 times the square root of this, because that's the power of a half. And then you've got minus 3 times a half is 3. And then the denominator is 2. And this is a minus square root, so it goes under the line. Okay. And then to write that as one fraction, this is our common denominator. Okay, 2 root x minus 1. So we have to multiply this by 2 root x minus 1. So you get root x minus 1 by root x minus 1 is just x minus 1. So what I did here was take out the 3 over 2. Okay, and you got root x minus 1 minus 1 over root x minus 1. Okay, so I just factored out the 3 over the 2. I wrote it out in front. And then I'm just multiplying this by this because to add and subtract whole numbers, I have to multiply by the common denominator. And a square root by itself is just x minus 1. I still have this minus 1, and my denominator is that. So that's x minus 2 over 2 root x minus 1. Okay?
Yeah.
So algebra comes in a lot here, and as do your indices, your rules of indices. So you have to get very familiar with swapping between the halves and the roots and back again, and the minuses and the pluses and back again. And you also say you need to be strong on adding and subtracting fractions. Question 19, you were given that this was y and this was dy dx. Okay, and you were also told that a, b, and c are constants. So it's a case of don't freak out because you see extra letters in here. Just treat them like numbers. So if we differentiate the x cubed, if this was like 5, you'd have 3 5s is 15. Just because it's an A, it becomes 3A. And then the power goes down by 1. Then you've got 2 by 2b, which is 4b, and the power goes down by 1. And then you have 3c by 1, which is 3c, and the power goes down by 1. Does that make sense?
Yeah.
Okay, so constants, other letters, apart from x, just like you multiply, add, subtract, divide them. Okay, so 3a's is 3a, 2 by 2b is 4b, and 3c by 1 is 3c. And we're told that that is equal to this. So you write down that dy dx is also equal to this. And then we know if they're equal, then the x squareds on both sides have to be equal, the x's on both sides have to be equal, and the numbers on both sides, the constants, have to be equal. So 3a, taking the x squareds, 3a is equal to 6, so a would be 2. Taking the x's, 4b is equal to 6, so b would be 3 over 2. And taking the numbers, 3c is equal to negative 6, so c is equal to negative 2. Is that all right?
Yeah.
Okay, and then question 20, I'll do that over here, yeah. So 20 is root of 4x over x plus 3. And first of all, get rid of the square root. So you write that as 4x over blah to the power of 1/2. Now for the chain rule, I would differentiate this bit in the brackets. And then I would have 1/2 the brackets to the minus 1/2. So the 1/2 the brackets to the minus 1/2 is fine. I can just do that straight away. This is a little bit more awkward because it's a quotient. So I need to apply the quotient rule to get what the derivative of this is. So to differentiate what's inside the brackets, I need to go over to the side and break it down. The top is u is 4x, the bottom x plus 3. So that's my v. U prime is 4, v prime is 1, and then I use the quotient rule. I've got vu prime, so that's 4 by x plus 3 minus 4x by 1 all over v squared. Multiply that out, you've got 4x plus 12 minus 4x over x plus 3 squared, so that's 12 over x plus 3 squared. So you then go back and put that in here. So the derivative of this is that, which you have to use the quotient rule for. Then the derivative of the root is 1/2 times that to the minus 1/2. Now, a little bit of algebra trickery here too. So 12 over 2 is 6, and I have the x plus 3 squared there. Because this is a minus, I would put 1 over this, okay? But 1 over a fraction is the same as the reciprocal of a fraction. So what I've done there, reciprocal means turn it upside down. So the x plus 3 goes on top and the 4x underneath. So if you look at that, if you have a fraction to the power of minus 1, that's 1 over. Minus the power means 1 over. So 1 over a over b. And if you're dividing by a fraction, you turn it upside down and multiply. Keep the top, change that to multiply, flip the bottom, which is b over a. So if you have a fraction to a negative power, it's the reciprocal of the fraction to the positive power. So that's what I did there. Do you want me to go through another example of that, or is that okay? Yeah, you just turn it upside down to make that flow.
Okay.
And then 6 over 4. Sorry, 4 to the power of 1/2 is 2. And 6 over 2 is 3. You still have, actually that x should have been there. So you should have an x there as well. Sorry. X to the power of 1/2, that's root x. Okay. And then we have x plus 3 squared here and 1/2 here. So 2 minus 1/2 is 3 over 2. Okay, see this and this. If you have a to the power of 2 times a to the power of minus 1/2, because we bring this down to be minus 1/2, then that's a to the power of 3 over 2. Okay, so that partly cancels the 2. And then you sub in, so f of 1 is 3 over root 1 is 1. 1 plus 3 is 4 to the power of 3 over 2. And you can do that in your calculator, but 4 to the power of a half is 2, 2 cubed is 8, and you have 3 above the line, so 3/8. Okay, so a lot of algebra in it. But when you see chain rule, basically what you have to differentiate what's in the brackets, and you may need to use the quotient of the product rule to do that, and then you have to differentiate the overall function, which is bring down the power and subtract 1 to get the new power. Okay, so you're multiplying the derivative of this times the derivative of the half, if you like. Is that okay?
Yeah.
Now, the next chapter is a lot easier. Second derivatives. All this basically means you'll see d2y dx squared, or f with 2 dashes. And what it means is you get the derivative, and then you just do the whole thing over again. You get the derivative of the derivative. Okay? And the reason why we use that is if you think of velocity is a rate of change of distance, agreed? So the speed would be dy dx. And then if you wanted to get the acceleration, that's the rate of change of speed. So that's d2y dx squared. So that's the reason when you have second derivatives, it's the difference between velocity and acceleration. Sorry, my book isn't coming up on my app, so I'm just trying to get it up online. Just bear with me a sec. Guys, what page are we on?
285.
Right, so, sorry, this is a bit smaller. So for any function, what we've been doing is deriving it or getting the derivative, finding the derivative, getting dy dx or f dash of x. If we differentiate that, then we get the second derivative. Okay, so you write it as d2y dx squared to show that you've differentiated twice, or f with 2 little dashes instead of 1. And how we pronounce that, it's d2y dx squared. Okay, and dy dx is the slope of the tangent, so d2y dx squared is the rate of change of the slope. Okay, so it's the rate at which the slope is changed. And in the real world, dy dx would be the speed, d2y dx squared would be the acceleration. Okay, so example 1 there, right, x plus 1 over x. That's just, sorry, I'm just going to write them down and then flip back to my pages. So y is x plus 1 over x. Okay, so right. So this is my y, and I'm asked to find d2y dx squared. So first of all, this is not in the form I want, so I change it to what? X to the power of what? What's 1 over x? X to the minus 1. We're just changing the power for now. We're not differentiating yet, okay? So dy dx, if I differentiate this, I bring down the 1, that just becomes 1. And then this, I bring down the minus 1, so that becomes minus 1 times x, and then take away 1, x to the minus 2. Okay? Now, I'm not going to change it back yet because I have to differentiate again. d2y dx squared, you just differentiate this. So the 1 is a constant that disappears, bring down my power. I've got minus by minus 2 is plus 2, x, and I take away 1, the new power is negative 3, and that's just it. Okay, so you just differentiate it. Don't bother changing back roots or minuses or anything. Differentiate it again. Is that okay?
Yeah.
And then the next one is, this is what we call a differential equation. These are used a lot in simple harmonic motion and electricity and all sorts of kind of real world problems, but basically relating the acceleration, the speed, and the distance. Okay, so find dy dx first. So let's rewrite this, 3x to the minus 1 plus 4x, okay? So differentiate that. I've got minus 1 by 3 is minus 3x to the minus 2 plus 4. Is that okay?
Yeah.
And then differentiate it again. We've got minus 3 by minus 2 is plus 6. X, take away 1 is minus 3, and the constant disappears. So differentiating is easy. Then show that this is true. So I write it down, x squared, d2y dx squared is this. So it's x squared times 6x to the minus 3, plus x times dy dx, which is minus 3x to the minus 2 plus 4, minus y, which is minus 3x to the minus 1 plus 4x. And I'm using brackets for all of these combinations. I want to show that this is equal to 0. Okay? So all I've done there, I have the x squared, sub in my expression that I worked out, plus x times this one, minus y, which was this. Okay? Now, do your SNL. So that's 6 is the numbers. X squared by x to the minus 3 is x to the minus 1, because when you're multiplying the base, you add the powers. 2 minus 3 is minus 1. SNL, so plus by minus is minus. Numbers is 3. And then x by x to the 1 by minus 2 is x to the minus 1. Okay, is that all right? 1 minus 2 is minus 1. Plus by plus is plus, numbers 4 and letters x. Minus 3, x to the minus 1, and then minus by plus is minus 4x. And if you group your like terms, you've got x to the minus 1, x to the minus 1, x to the minus 1. You've got 6 minus 3, which is 0. So that cancels that. And then 4x minus 4x cancels, and you're left with 0. Okay, so these look like horrible equations, but it's not really that bad, okay? It's just a little bit of algebra. You just sub in, you work this out, you sub it in, you work this out, you sub it in, and you do out your multiplication, okay? Any questions on that?
So at the very end it should equal to 0?
Yeah, it said show that this expression is equal. Okay, that was example 2 in the book. And then, okay, so we could. Just give me 1 second. Okay. So this is a nice easy one, okay? So 7.6, you can do 1, 3, 4, 6, 7, 9. And 11 and 14. So 1, 3, 4, 6, 7, 9, 10, 11, 12, and 14. Okay. So I'll put them up in Classroom now. We can get started on this.
And I'm just a young nigga with some romance.
Everyone doing okay?
Yes.
No remorse, no regret. Devil playing the saint. Under my skin, lose myself because she's not like the other girls. Always ready to win. Under my skin, go away, my queen of sins. I'm not done, but what if I am? 'Cause I don't know where we are, how you've been under my skin. Whoa, heroína, whoop, whoop, heroína, whoa, heroína, man. Whoa, heroína, whoop, whoop, heroína, whoa, heroína, man. Oh, yes, that day in my bed. She stole my heart and my head. What's the point in playing dead when
Okay, I'm just going to stop sharing the screen because I want to check something here, but I am still here. Okay. Ask anything.
the kind of love you want? And I ran out of self-control, you know what I mean? This labyrinth still can flow, and there's you under my skin. Whoa, heroína, whoop, whoop, heroína, whoa, heroína, man. Whoa, heroína, whoop, whoop, heroína, whoa, heroína, man. And every time we're meeting, we're playing games, we're cheating. Inside our chests are beating the many hearts you stole from other men. Whoa, heroína, whoop, whoop, heroína, whoa, heroína, man. 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 Devil playing the saint under my skin, lose myself
Miss, could you go through the first one, please?
No problem. I'm back on screen sharing. One sec, sorry. Now, so the first one is that x cubed plus 2x squared? So y is equal to x cubed 2x squared. So dy dx, what do you get if you differentiate x cubed?
I can't remember.
Right,
3x squared.
3x squared. Yeah, bring down the 3, take away 1. Then this one, you bring down the 2, so 2 2s is 4, take away 1 to get your new power. And then d2y dx squared, you're just ignore y and you're differentiating this new one. So bring down the 2 multiplied by 3x, and the new power is 2 minus 1 is 1. Bring down the 1, 4 ones is 4, and the new power is 0. And that's it.
All right.
Any of the ones that are written as, like, say, the next one where you've 1 over x, write it as x to the minus 1, and leave it in that format till the very end. So you apply your rule. So bring down the minus 1, you've got minus 1 times x, take away 1 is minus 2. Apply your rule again, d2y dx squared, you bring down the minus 2, so minus by minus 2 is plus 2, x to the minus 3, and now you change it back to normal, so it'll be 2 over x cubed. Okay, so these first few questions are good practice at just basic differentiating and swapping all your, back and forth between your types of powers. Is that okay?
Yeah.
You doing okay?
Yeah.
Yes.
Yeah.
For question 4, when you have the fractions 1 over x squared, when you're
Yeah.
like changing it, does it become x to the power of 1?
No, but, so the 1 over x squared becomes x to the minus 2. So the first thing you do is change your y into a format that you can use your differentiation rule for. Then you take the x to the minus 2 and you differentiate that, and you have the 3x squared, you differentiate that. So the minus 2 will become minus 2 times x to the minus 3. Now to go through that on the camera.
Yeah, please.
So you have is equal to 1 over x squared plus 3x squared, was it? Over x squared plus 3x squared. Yeah. So before you can differentiate that, you have to get this into the form of x to the power of something, which is x to the power of minus 2. Okay, so far I haven't done any differentiating. I've just changed this into a format that I can differentiate. Because my rule says dy dx is n times x to the n minus 1. Okay, bring down the power and then change it to a new power. So dy dx is minus 2x to the minus 3, okay, because bring down the minus 2, take away 1 to get the new power, and then this one I bring down the 2, 2 3s is 6, and take away 1 to get the new power, which is just 1, and I don't bother writing that. Now I start all over again, and these are both in formats, they're in a format of x to the power of. So I bring down the minus 3, I've got minus 2 by minus 3 is 6, take away 1 to get my new power. Bring down the 1, I've got 6, take away 1 to get my new power. Okay, so that's it differentiated now, twice. If you want to put this back into normal format now, we bring the x to the minus 4 below the line, so you've still got the 6 above, and that's 6 over x to the power 4, and then you have the plus 6 there. Okay?
Good.
So the first thing you want to do is change your y into some sort of x. Y has to be in the form of x to the power of n before you can differentiate. So that's the first step, is change your y. Then you go ahead and do your differentiating. And for all of these, you're going to do it twice. And like for question 10, find your d2y dx word, hence find the values for which that equals to 0. Well, once you've worked it out, just let it equal 0 and solve for x. Everyone else okay?
Yeah.
Okay, let me know. So lads, I'll put up videos of them all anyway, and see you tomorrow, okay?
Thank you.
Let me know if
Thanks.
you're stuck on it.
Thanks, Beth.
Thanks.
Okay, mind yourselves.